So based on this reflection exercise, I'll go through what we're going to be covering in this week's lecture. So the first thing is we go into details about the definition and provide you with a solid understanding and a solid introduction to the term geodesy and what it entails. Then from there, we're going to go through our 3 reference systems that we use in geodetic surveying. So looking at the solid Earth model, the geoid model, as well as the ellipsoid model. And our reference systems, we refer to those as datums. And our ability to be able to understand the relationship between these datums, so going, for instance, between the geoid and the ellipsoid, and understanding how they fit in with each other. So starting with the definition of geodesy. Geodesy is a combination of 2 words, geos meaning earth, and desi means the study of. It's quite a old science. It's been around for a very long time. I've actually included a couple of readings that take you through some of the history of first are the pioneers when it came to geodesy and geodetic surveying, and how this model of the surface of the Earth came about. It's currently defined as the branch of physical mathematics that deals with the shape and the area of the Earth or of large portions of it. So again, it doesn't deal with localized areas. It's more for larger scale areas that are going beyond a certain distance, as well as looking at the Earth as a whole, so the entire surface of the Earth. And it combines other sciences that not just only deal with the shape and the size and the shape of the Earth, but it also takes into account physical properties related to the Earth. So things like the Earth rotation, the effects of gravity, tides, crustal movements, so tectonic plate movements, as well as relating our Earth observations with our terrestrial observations, celestial observations, so other planets as well. Geodesy has, over the years, as it evolved, have also used positioning using astronomical observations. So as I just mentioned, so astronomical observations were developed where we used to position on the surface of the Earth using celestial bodies. And that evolved to the current modern times where we're using satellites, which in a way mimic those celestial bodies. So these are the basis of our GNSS, Global Navigation Satellite System techniques, of which you're probably familiar with the term GPS, Global Positioning System. And that's just one particular type of GNSS. So here I'm going to highlight again some of the complexities that the science of geodesy has. And when we're looking at the surface of the Earth overall, obviously the Earth is made of over 70% of water, and the remainder is covered by land masses. So because of that, we know that the distribution of land masses all around the Earth does influence gravity. And gravity is one of the main fundamental studies that deals with geodesy and how the Earth is modeled based on gravity. So geodesy is the science of measuring the shape and size of the curved surface of the Earth and being able to take those measurements and representing them in appropriate ways depending on what the end user wants. And a lot of the times it's representing them in maps. So projecting a curved surface into a flat surface like a map, or a physical map, or even a digital map, so on a screen. And the complication that comes with geodesy, again, refers to the physical shape, size, effects, and how it changes over time. So the Earth is always moving, it's dynamic, and we already know that because we've been studying the crustal movements of the Earth for a long time, and obviously seeing the effects of the crustal movements when it comes to earthquakes, volcanoes, things like that. Being able to study that and then account for the effects of changes in the surface of the Earth over time, so that we are not impacting our observations, survey observations. So again, I'll focus more on that as we progress through. Okay, so this is now going and defining how geodetic surveying relates to our everyday surveying. So we know that there's this concept with surveying of working from the whole to the part, and you should know it by now because you would have covered it multiple times in our diploma already. But it basically tells us that all throughout our the world, and maybe say in specific areas of the world, we have points that are positioned in a network, and they're positioned quite accurately, and they're able to determine the position of these points with respect to each other. And from that, we have a reference system that we can then use to drive all the necessary information for our localized surveys. So this is the foundation of all surveys. Geodetic control networks that are created based on high accuracy position reference points, and then they guide the entire framework for our national topographic surveys. Okay. So there's a bit of history about how geodetic surveys came to be. So throughout times, again, I've included a couple of links for you on Moodle. Have a read of them just to see when was the time that people have actually started being interested in the idea of an Earth being spherical rather than a flat Earth. Because throughout history, there has been a lot of resistance about whether or not the surface of the Earth was curved or if it was flat. So it began with people observing, or simply observing, that when vessels were going to the disappearing through the horizon from the view of a person standing on the shore, they noticed that the lowest part of the vessel would disappear first, and the mast would be the last to vanish. So obviously from there, they started to hypothesize, you know what I mean? So they started to come up with this idea that as we were traveling away from view, the mast was the last to disappear. So the Earth must be curved in some way. The other thing that was initially noticed was that the length of shadows were changing as a person traveled north to south. So again, bringing that idea that yes, the Earth could potentially be round. So that's when the idea of a flat Earth began to change. So I'll let you go and have a read of the history of geodesy. So one of the references is a short video, and it will give you a good, solid kind of overview of what the whole topic of surveying geodetic surveying as it relates to our profession as surveyors.